Now we're going to graph some reciprocal functions. Graph y equals 2 times the cotangent of x over 3. First we have to get it in the proper form. Y equals a times the cotangent of k parenthesis x minus b, close your parentheses, plus c. In this case, if we take the given equation, we can write it in that form with y equals 2 times the cotangent of, factor out the 1/3, times parenthesis x minus 0, close parenthesis, plus 0 on the outside, indicating that a is equal to 2, k is 1/3, b is 0, and c is 0. Now take a look at note 161 at the graph of the basic cotangent function. From there you'll notice that we can get information to a complete step 1. Now for step 1 here we're going to do asymptotes. There is no amplitude because there are asymptotes in the cotangent graph. So step 1 will be the asymptotes. Now we know that the cotangent of x has the following asymptotes from note 161. We have an asymptote at y equals 0 and y equals pi. And the graph actually has a root or a 0 at pi over 2, and it looks like this. It's asymptotic through the 0 and then asymptotic again. And that's one complete cycle from 0 to pi. So you see the asymptotes in the original basic graph for cotangent are x equals 0, x equals pi, etc. So to acquire the new asymptotes, we just take the old asymptotes, divide them by k, and add b. So in this case, the k value is 1/3, which dividing by 1/3 is the same as multiplying by 3. And then we're adding 0 because b is 0. So we get the new asymptotes at x equals 0, and x equals k over 1/3 plus 0 is 3 times pi. I'm sorry, it's pi. When you divide by 1/3, it's the same as multiplying by 3, so it's 3 pi. Step 2, the old interval of interest from note 161 were x values between 0 and pi. But you'll notice it was never equal to 0, nor were the x values equal to pi. So we have an inequality with no equal portion in our inequality signs. That's very important. Those are asymptotes there. The new interval of interest is acquired by using the same extremes, 0 on the left, pi on the right, the same symbols with no equal portion. And in the middle, stick in there k parenthesis x minus b. K is 1/3, b is 0, so in the middle we have 1/3 times x minus 0. Solve for x in the middle by multiplying all three regions by 3. We get 0 less than x less than 3 pi. That's our new interval of interest. Our new period is the final x value in the interval in step 2 minus the initial x value, so it's 3 pi minus 0, it's 3 pi. Our old key points from note 161. Now there were asymptotes here, so it was a little strange. Our first value was x equals 0, but we were only interested on the right side of that 0. So it's 0 plus. Then there's pi over 4, pi over 2, 3 pi over 4, and then pi from the minus sign, from the negative side, At 0 on the positive side, the y-coordinate is approaching infinity. It's undefined. Then we have a 1 y value, a 0, a negative 1, and then at pi approaching from the negative side, we have the y value approaching negative infinity, undefined. So our new key points are acquired. First of all, the new x values are acquired by taking the old x values, dividing by k, which in this case is 1/3, adding b, which in this case is 0. The new y values are found by multiplying the old y values by a, which in this case is 2, and adding c, which is 0. Okay, so we use the appropriate k, a, b, and c. We'll have our new x values equal to 3 times the old x values, and our new y values equal to 2 times the old y values. So just grab those new old x's and old y's, put them through these modifications, and we have 0 for our first x value, but we're only interested on the positive side. We have an asymptote there, so y approaches infinity, positive infinity, it's undefined. Then we have 3 pi over 4. At 3 pi over 4, y is equal to 2. At 3 pi over 2, y is equal to 0. At 9 pi over 4, y is equal to negative 2. And at 3 pi from the negative side, the left side, the y value approaches negative infinity. It's undefined there. So let's do our graph. of y equals 2 times the cotangent of x over 3. We have an asymptote on the y-axis and an asymptote at 3 pi. We only are interested in the interval from 0 to 3 pi. In the halfway point, it's 3 pi over 2. Halfway in from 0, that's 3 pi over 4, and halfway on the other side, it's 9 pi over 4. And then our values for the y-axis are 2 and negative 2. We don't need those ones. They're not important. We just have our 2 and our negative 2. Now let's graph the points. Now what I want you to notice, as we approach 0 from the positive side, the y values go up to positive infinity. That's why there's an arrow. And as we approach 3 pi from the negative side, they go down to negative infinity. We have the point 3 pi over 4 has a y value 2, 3 pi over 2 has the y value 0, and 9 pi over 4 has the y value negative 2.